Good morning, everyone. In this lecture, I'm going to tell you about how to convert a regular expression into a deterministic finite automata. In previous lecture, we studied about its vice versa. That means we converted a DFA, given DFA, to a regular expression. Now here we are doing its opposite. So let us start with this topic. So these are the steps which you have to follow while converting a regular expression, a given regular expression, to a deterministic finite automata. So what are these steps? First of all, you have to append an hash symbol in any given regular expression in such a way that string generated by that regular expression consist of hash at the end. Each and every string should consist of hash at the end. You have to append that hash symbol in such a way. Then in second step, what you have to do? In second step, you have to number the operands along with the hash. Hash will also be considered as an operand. Now you have to number the operands from left to right, from 1 to whatever operands you have. In the step 3, you have to find follow pause. Now follow pause is a short form of following position of each operand. Each and every operand, that means you have to find the operands which have possibility to come in following position of any operand, any particular operand. You have to find those possibilities. In step 4, what you have to do? In step 4, you have to find out the operands by which string will always start in the language set, and will make it as our initial state of the resultant DFA. Now you have to find out the transition, all the transition of all input alphabets one by one, uh, from initial state till the new states are being obtained. When once you stop, once you are stopped, you stop getting the new states, you have to decide the final state. So whatever state is consisting of hash, the number operand number of hash symbol, that state will be considered as final state. So let us uh, take an example and we'll see how this process is done step by step. So this is a question in which you have got a regular expression, that is a plus b raised to the power asterisk abb. Now we have to convert this regular expression into a DFA. So what we have to do, according to step number 1, we have to append hash symbol in this given regular expression in such way that each string is generated by this regular expression should consist of that hash symbol. So what we will do, we will append hash simply like this. Okay. Now, why I'm saying in such a way that every string is generated by the regular expression. So let us take an example and I'll tell you why I'm saying so. So suppose if it is written like this, a asterisk b plus b. Suppose you've got a regular expression written like this. Now you cannot append a hash uh, symbol in this regular expression like this, because in that scenario only this ba string will consist of hash at its end. This a asterisk b, the string, all these strings generated by these a asterisk b will never consist of this hash at its end. So what we have to do, we have to use these bracket signs, this bracket first of all, and then we will append the hash symbol. Now you will be able to understand why I'm saying so, that each string generated by regular expression should consist of hash at the end. So you have to keep this thing in your mind. Now here if I talk about this example, there is no problem, because abb will be at trailing end of each string. So I have appended hash simply without using any bracket. Now in the second step, what I'll do, I will number each and every operand. So I will number it out. So along with hash also. So I have marked from left to right. So I will mark 1, 2, 3, 4, 5, and hash also 6. So these are the numbers which I have assigned to these operands. Now in step 3, I said that I have to find the following position of all the operands over here. So I have kept this numbering on the right hand side of the screen. Now I will make a table for follow pause or following position, if I say completely. So how I'm going to find out its follow pause. So first of all, I will consider one. So what is one? One is actually this A I'm considering. Okay, I have named this A as 1. So what are the possibility? What operands will follow this A? What are the possibilities existing here? So as it is written here, A plus B whole asterisk, A plus B raised to the power asterisk. That means any possible combination of A and B, including epsilon. That means a single A can also come, and 2A also can also come, 3A, 4A consecutively A can also come. So it means that after this A can be repeated. So that means in the following position we can place 1 over here in the following position of 1. Second thing, that after this A, B can also come, because this is actually, this means actually any possible combination of A and B. So what is actually any possible combination of A and B means? That means any number of A's, any number of B's, or any number of A and B in any combination. Okay, so B can come after this small a, that is 1. So we can write 2 also in the follow pause of 1. And suppose this B became epsilon, because I have told you that this is any possible combination of A and B, including epsilon. So if I say this B becomes epsilon and this B is removed from here, then what is the possibility? That this 3 can also come right after this one. So what are all possibilities? That 1, 2, and 3. These three things can come after, it can come in following position of this operand 1. Okay, 4 will never come, because this 3 will be existing every time between this complete thing and this 4. 3 will always be there. So 1, 2, 3 is the answer. So I will write out following position of 1, that is 1, 2, and 3. Now talking about 2, the same thing will happen. If I consider this 2, that means this B, and try to find out its follow pause, what are the possibilities of operands in its following position? Again, I said this B, A plus B raised to the power asterisk, means any possible combination of A and B, including epsilon. That means after B, this A can also come. After B, this B can also come, because B can repeat any number of times. And if this A becomes epsilon, or directly this A, which is named as 3, can also come. So I can say this, the possibility of following position of 2 is 1, 2, and 3, the same. 4 can never come, because 3 can never be made epsilon, because there is no clean closure over it. So 3 will never be removed from here. So 4 will never come into the following position of 2. So the answer is again 1, 2, and 3. So I will write the following pause of 2, that is 1, 2, 3. Now I talk about the following position of 3. So the following position of 3, if I talk about this 3, that is A, in the following position we can see directly that 4 is coming over here. Okay, so I will write 4 over here. Now is there any other possibility of any other operand after 3? No, because all this 4 will always come behind this 3, and there is no clean closure over it. So there is no possibility of this B of removing in any case. So after 3 only 4 can come. So I will write 4 in the following position of 3. So I will write it here like this. Now considering 4, that means this B. Now this B has always this B, means 5. This if I say it by the number, that in following position of 4, there is only possibility of 5 coming. Okay, so I have written I will write 5 in the following position of 4. And similarly, in following position of 5, 6 can only come. There is no other possibility. And in the following position of 6, nothing will come. So I will write 5 over here. Okay. So this is the way how I will find out the following position or follow pause of the operands. Now, what is the next step? In the next step, I will find out the initial state of the machine. So what I'll do, I will try to understand that this complete regular expression will generate what type of strings. Or in other words, if I say, what are the operands by which the strings will always start? So there is a possibility that one will come in the string at the first place, or there is a possibility that two comes at first place, because any possible combination of A and B can come. So B can also come at first place. And if I say that this both A and B becomes epsilon, so let us consider that both this A and B becomes epsilon because it is a clean closure. So in that case, string will start from this 3. Okay, but this third A or 3 will never vanish from this regular expression. So the only possibility of the strings will starting from 1, 2, and 3. So in our DFA, the initial state will be 1, 2, and 3. So let us make it here. So what I have said you is marked over here also. So 1, 2, and 3 are the possibilities of starting of the string. So I will make an initial state 1, 2, 3. So let us make it here. Yes. So I made an initial state 1, 2, 3. Now my task is to find out all the transition and new state, whatever can be formed. So how to make further states? So first of all, what I have got in my hand, I have got 1, 2, 3 in my hand. Okay. The existing state is 1, 2, 3. So what I'll do, I will check out here that in 1, 2, 3, what symbols are A and what symbols are B. So if you see here closely, only 1 and 3 are A and 2 stands for B. So 1 and 3, follow pause of 1 and 3 will be combined and the transition of A will be drawn. So 1 and 3, follow pause of 1 and 3 are 1, 2, 3, and 4. So what I'll do, and the follow pause of 2 is 1, 2, 3 only. So what will happen? For A transition, it will reach to some new state 1, 2, 3, 4, and for B transition, it will reach again to 1, 2, 3, the same state, like this. Now I've got a new state 1, 2, 3, 4. So I will repeat the same step there, that in 1, 2, 3, and 4, I will classify what all numbers are A and what all numbers are B. So in 1, 2, 3, 4, if you see 1 and 3 are A and 2 and 4 are B. So I will combine the follow pause of 1 and 3. So it will be 1, 2, 3, 4 and make transition of A. So and in this, just a second, in this way. And if I say follow pause of 2 and 4, it will result in 1, 2, 3, and 5. So I will make B transition with 1, 2, 3, 5. Now I have again got a new state 1, 2, 3, 5. So again I will classify its A and B numbers. So the numbers 1, 2, 3, 5 in 1, 2, 3, 5, 1 and 3 are denoting A and 2 and 5 are B. So what I'll do, I will combine the follow pause of 1 and 3 and make a transition, make a new state of A transition. So 1 and 3 will constitute of 1, 2, 3, 4. So there is no need to make a new state. 1, 2, 3, 4 is already existing in our figure. So what I'll do, I will make a transition over here from 1, 2, 3, 5 to 1, 2, 3, 4. And 2 and 5, follow pause of 2 and 5 will be combined. It will give 1, 2, 3, and 6. So a new state will be made because 1, 2, 3, 6 is not here in our machine. So this is the A transition and this is the B transition. Now considering 1, 2, 3, 6, another new state we've got. Again, the same process will happen. In 1, 2, 3, 6, 1 and 3 are A and 2 is B. 6 will be ignored because 6 is neither A nor B, so it will not be considered in transition. So 1, 2, 3, in 1, 2, 3, 6, 1 and 3 are A. So again 1 and 3, follow pause of 1 and 3 will be combined. That is 1, 2, 3, 4. So I have got 1, 2, 3, 4 state. So what I'll do, I will make a transition over here, and follow pause of 2 will will help us in making B transition, and that is 1, 2, 3. So 1, 2, 3 state is also existing already. So this is the A transition. and this is the B transition. So now I have got no new states, so I will stop over here and I will decide the final state in my machine. So what is the final state? This state which is consisting the number of hash, okay, that is 6 will be our final state. So I have made it up as final state. Now this is the DFA, or this is the finite state machine which we have got from the regular expression which was given in the question. So this is the complete process of converting a regular expression into a DFA. In the same way, you can also try this process with this problem also. The only difference over here is that the only thing which you should keep in mind, that while appending hash, you have to use bracket over here, because if you directly append hash behind it, it will be wrong. Okay, and rest of the process will be same. Thank you so much. This was all about conversion of a regular expression to DFA. Thank you.